Hello, very good evening you all. Welcome to the video lecture part 3 on gear trains. In the previous class we have studied the types of gear trains and velocity ratio as well as train value. In this lecture we shall discuss about the very important methods to find the velocity ratio as well as the train value. The very first method is algebraic method. Let us see how actually we can able to find the velocity ratio as well as train value in a epicyclic gear train. First one, let us consider a epicyclic gear train. It is also called as sun and planet gear train because here the gear 2 is revolving around the gear 1 and hence gear 1 is treated as sun gear and gear 2 is treated as a planet, because as we have seen in a basic science that the planet revolves around the sun and it is also rotating about its own axis. In the same fashion, this kind of a gear train is nothing but a gear 2 which is treated as a planet gear revolves around the gear 1. Hence, this kind of arrangement is also called as sun and planet gear. Okay. So consider gear 1. As I said, it is also called as a sun wheel and it is treated as a driver gear. Gear 2 or planetary wheel, this one gear 2, it is also called as planet gear and it is treated as a driven gear. Okay, and 3 is the arm. So this is the simple epicyclic gear train. So in this, as we have already discussed in the previous lecture, that velocity ratio is nothing but the speed of the driver gear to the speed of the driven gear, or the number of teeth on the driven gear to the number of teeth on the driver gear. Here 1 indicates driver, 2 indicates a follower or driven. Okay, and the train value is nothing but it is just a reciprocal of velocity ratio, and hence train value can be defined as n23 divided by n13, because here 23 indicates the, here we are considering arm also, that's why it is simply a relative motion of a gear 2 with respect to arm to the relative motion of gear 1 with respect to the arm, and it is equal to minus z1 by z2. See here it was z2 by z1, but now it is a reverse, minus z1 by z2, and minus sign indicates that both driver gear as well as driven gear are simply the first gear and last gear rotates in a opposite direction. That's why negative sign is taken. Suppose if we consider one more gear here, then the odd number of gears are formed. As I said in the previous lecture, that if the odd number of gears are present, then the first gear as well as last gear will rotate in the same direction. Then here we have to take positive in that case, but in this case it is negative because first gear and last gear rotates in the opposite direction. Okay, then let us define this. What is n23 and n13? The speed of the wheel 1 relative to the arm 3 is nothing but n13. Okay, so n1 minus n3. Here relative speed is nothing but the difference between the gear 1 speed and arm speed. As we know that gear is having a motion faster than the arm, that's why n1 minus n3 it is n1 minus n3. Similarly, speed of the wheel 2 relative to arm 3 is n23, that is n2 minus n3. Now the equation 1 becomes train value is nothing but n2 minus n3 divided by n1 minus n3 is equal to minus z1 divided by z2, or it is generalized expression can be written as nl minus n arm divided by nf minus n arm. Here nl is nothing but speed of the last gear minus speed of the arm divided by speed of the first gear minus speed of the arm is equal to this minus z1 by z2 quantity. We have to equate it. So this is simply a method to find the train value of a given epicyclic gear train. Okay, this is a first method. Second method we'll study it later. So based on this method, we will solve some numericals. Okay. After that, we'll go to the, or we'll move to the second method. Okay. Let us move to this particular question. Okay. So here, two spur gates A and B of an epicyclic gate train is shown in the figure. Have 24 and 30 teeth respectively. The arm rotates at 100 rpm clockwise direction. Find the speed of the gear B on its own axis when gear A is fixed. If instead of being fixed, the wheel A rotates at 200 rpm in counterclockwise direction, what will be the speed of the B? First, understand the physics of the problem. That is, here the two questions are given. One is, find the speed of the gear B, that is gear B, on its own axis when A is fixed. You need to find the speed of the B when A is fixed, and when this when the gear A is rotating at 200 rpm in the anti-clockwise direction, what will be the value of speed B? Okay, these are the two questions we needed to answer it. First, write down the given data. Speed of the arm is given 100 rpm clockwise. Clockwise values are taken as positive and counterclockwise values are taken as negative, that you already know. And ZA, that is number of teeth on the gear A, is given, it is 24, ZB is 30. Consider the gears A, B and arm. Let gear A be the first gear and this is the last gear. Then how did you define the train value? It is number of teeth on the driver to the number of teeth on the driven. Here what? Which is the driver? Definitely A is the driver and B is the driven. So it is defined as minus ZA by ZB. Why? Because ZA is a driver, ZB is a driven, and here negative sign indicates both are rotating in the opposite direction. See, if gear A rotates in a clockwise direction, definitely B rotates in the anti-clockwise direction. That's why negative sign. Minus 24 by 30. And we know that general expression for the train value in case of epicyclic gear train is speed of the last gear minus speed of the arm divided by speed of the first gear minus speed of the arm. So here last gear is what? It is B. NB minus N arm divided by speed of the first gear is what? First gear is A. So NA minus N arm. Simply in the next step put the values of these things. Minus 24 by 30, keep it as it is. NB minus N arm, NA minus N arm. Now, let us use the first case. What the first case suggests is, when the gear A is fixed, what is the value of gear B speed that they are asking? So, gear A is fixed, it simply means that there is no speed in case of gear A, means it is fixed one. So, speed of the gear A is 0 and N arm is equal to 100, it is given. Just put in the equation number 3. So, minus 24 by 30 is equal to speed of the gear B minus 100 divided by NA is equal to 0. See here, NA is equal to 0 minus 100. Just simplify this. NB minus 100 keep as it is. Take this minus 100 this side, then multiply with this value. Okay, so we'll get the speed of the gear B as 180 rpm clockwise. If we get the value positive, write clockwise, otherwise it is anti-clockwise. Okay, now second expression, what says is, when the gear A rotates at 200 rpm counterclockwise, remember it is a counterclockwise. In this case, you have to take it as a negative sign. NA is equal to minus 200 and N arm is already given 100 rpm. Then what will be the speed of B? Again these data just put in the equation number 3 again, because this is what? The generalized expression. Okay, so that's why again minus 24 by 30 is equal to NB minus 100 divided by minus 200 minus 100. This minus 300, take it this side and simplify. You will get speed of the gear B as 340 rpm counterclockwise. Again you will get positive value, so this becomes a clockwise direction, NB 340 RPM. So this is the method to find the train value as well as the speed of different gears. Okay, next question is an epicyclic gear train shown in the figure 7.6. The number of teeth on wheel A, B, C are 48, 24 and 50 respectively. If the arm rotates at 400 rpm clockwise, find first one, speed of the wheel C when A is fixed. Second question, speed of the wheel A when C is fixed. Vice versa is given. Let us see the solution for this. Okay, here is the given figure. It is given that teeth on the first gear is 48, teeth on the second gear 24 and 50, and speed of the arm is given it as a 400 rpm clockwise. So now let definitely A be the first gear and C is the last gear. So now the first gear A and the last gear C rotates in the same direction, isn't it? If this rotates clockwise, this is anti-clockwise, again this is clockwise. So both first and last gear rotates in the same direction. Now train value is defined as number of teeth on the driver by number of teeth on the driven. Driver has 48 number of teeth, driven gear has 50 number of teeth. Hence ZA by ZC is nothing but 48 by 50. Now train value is nothing but what? Generalized expression, speed of the last gear minus speed of the arm, speed of the first gear minus speed of the arm. So here last gear is C, speed of the NC minus NR divided by NA minus NR. Now let us write it here. 48 by 50 is equal to NC minus NR, NA minus NR. Now first question, what he has asked is, when gear A is fixed, what is the value of gear C? That he has asked, right? So now gear A is fixed means speed is 0, then NA equal to 0 and NRM is equal to 400. Let us use these substitution in this third equation. Now 48 by 50, NC we need to find out minus 400. This is the speed of the arm divided by speed of the gear A. As it is fixed, it is 0 minus 400. Now speed of the wheel C is, just take this minus 400 this side and simplify, you will get plus 16 rpm. It means that the last gear C is rotating in the clockwise direction. Okay. Now second condition is that when gear C is fixed, what is the value of gear A? That he has asked, right? Now substituting NC is equal to 0 and NRM is equal to 400 in the again generalized expression, that is this equation number 3. Now 48 by 50 is equal to speed of the last gear is fixed. Okay, last gear is fixed, it means speed is 0 minus 400 divided by NA minus 400. See, just I am substituting these values in the equation number 3. Okay. Now just multiply this minus 400 this side and simplify, you will get NA equal to minus 16.67 rpm. So here negative sign indicates that gear A is rotating in the anti-clockwise direction. Okay, so NA is equal to 16.67 rpm counterclockwise. Okay, let us see the next question in the next video.